Hello IB, welcome to a new topic. We're looking at statistics. So this is going to be a nice change from some of the rigour that we were looking at in trigonometry and a lot of pure algebra. This is another area of maths. It's really important. It's one of the other areas that you will use your maths outside school, because anything to do with insurance and, statistics comes into probability, probability comes into insurance. We've just been through a census where we had to give information about each household, and so a lot of government decisions are based on statistical evidence. So policies come out of statistics. Medical research, if they're researching something and they're looking at statistics on whether a medication actually makes any difference or not. So statistics is a very important area of maths. And so we'll get to look a little bit of it this year and then more next year, but it's certainly a long way from what you would cover if you were studying statistics at university. So the opening problem the textbook comes up with is the farmer who's looking at his growing peas and the effect that a fertiliser has on his production. And instead of just making a guess at it, I think it makes a difference, he's obviously in this case taken a whole lot of statistics. We've got a lot of data and wants to analyse it to see, does it make any difference? These terms over here on the right side, these ones here, are some of the terms that are important that we understand. So let's spend a bit of time going through this. You would have done statistics before, so a lot of these terms should be familiar. So the key concepts here, definitions of a population. What do we mean by a population? That means the whole group of people or things that we're studying. And if we want to get data about the whole group, then we're obviously going to do a census which investigates everybody. It gets data from the whole population. But often doing a census is expensive and can run into IT problems like this time. And so we often take a sample, which is some smaller group or subset of the population. The key thing here is that when you take a sample, we want to make sure that our sample is random. All right, that means it's randomly selected so that we don't introduce bias. Bias means it's distorted, and so the results would be distorted. And so the best way to avoid bias is to take a random sample. And pulling numbers out of a hat or using a random number generator is the best way of doing that. So when we just take a sample and we get the data from that, we're actually just carrying out a survey, and that's the difference between that and a census. A survey is where we've just got a smaller group of people or things and we gather the data. When we think about data, you should remember that you would have talked about different types of data. We're either going to have a data that's going to be categorical, and that means there's some quantitative characteristic or quality that we're measuring, or it could be quantitative, where it's to do with numbers. So an example of categorical or qualitative data would be things like, if we're picking, say, eye colour, all right, or favourite food, favourite movies, all of those things, where they're just a description. Numerical data is where, when you answer the question, you're involving some sort of number. So it could be how old, all right? So in other words, age, or it could be how many apps do you have on your phone, all right? So, on the phone. So anything where a number's answered, how many siblings, how many mobile phones in your household, things like that. We'll put a double P there so it looks better. All right, okay. When we come to numerical data, there's two types of numerical data. One's called discrete and the other's continuous. Discrete means it's made up of whole numbers. So that's what we mean by the term discrete. So if we're talking number of apps or number of siblings, whole number, then that's a whole number. And we get that whole number from counting. All right, so example, how many whatever, all right, because we're going to count that. How many siblings? Whereas the continuous variable, that's something we get from measuring. So we might be measuring, if we look at the example we had above, how old you are, we're going to measure that in years. And you're not going to be just 1 year and then 2 years. It'll be continuous, what the answer could be. You could be 1 year, 3 months, 4 days, 2 hours, 10 seconds. Or another example would be how tall you are. What's your height? And you're measuring it off some sort of instrument in that case, and the accuracy depends on how accurate your instrument is. So continuous data, where the numbers can be anything, any real number, limited by your measuring instrument, or discrete data, where you're just counting up objects or things. A parameter, that's another term. We've looked at parameters as other letters in an equation, like our y equals mx plus b. M and b are our parameters. In terms of statistics, it's a numerical quantity describing an aspect of a population. A statistic is where we actually then start to do calculations based on our data. So a quantity in that case could be things like calculating the mean or the median. They're the common statistics that we'll come across. We've also, or you would have looked last year at the spread of data. So if we plotted it, we can get a spread that represents our data. So this could be along here, whatever the data is. The score, the amount, and on this vertical axis, we'd be looking at frequency. So we can see sometimes we get data that looks like that. It's like a bell curve, and it's very symmetrical. Whereas in this one here, it's not symmetrical. We get this long tail out to the positive end, like that way is going positive, to the left is negative. So we say the data is skewed, and because it's in that positive direction, we call it a positive skew. I'm going to work on my writing with this. This one, obviously, because the tail comes off to the negative side, then we call it a negative skew. So some data is quite symmetrical, others can be skewed by the environment that we're looking at. For outliers, all right, outliers are those bits of data that are outside the normal or the main group of data. So data values that are much larger or smaller than the general body of data. Now with outliers, generally we should include them if they're a valid piece of data. If there really is an outlier, then there is an outlier. But if you know that the data was recorded with inaccuracies, the instrument wasn't working, the person was lying or whatever, then that's when you should ignore them. But if there's no reason to think that it's not a valid piece of data, then you should include it and just accept the fact that that data might be skewed because of some outliers, either higher or lower. In terms of organising and displaying your data, this should be familiar as well. So having a frequency table where you've got the particular value or the data, the score that you're measuring. So these values here is your data, and your frequency column, how often it occurred. Your total, the total number of pieces of data you've got. Your relative frequency is going to be your frequency divided by the total number. So it's a fraction, right up here, relative frequency equals the frequency for that particular score divided by the total. All right, so it's that particular frequency over n, the total number of schools. So this would be 8 out of 30 for that relative frequency. So in a table is a good way of displaying your data. Otherwise, you're going to be doing these sort of graphs. This one here, the column graph, we use that for discrete data. So if it's discrete data, that means it's not connected, and so our columns are not connected. Obviously, we have the actual data down here, and we've got frequency up here. And so it might be how many shoes, or the size of your shoes. So if you took the shoe size of everyone in your class, each of these are discrete numbers. You're not going to have someone, like you might have a size, I'm a 7.5, but there's not a shoe size 7 3/4 or 7 and 7.8 or 7.9. It's either a 7, a 7.5 or an 8. And so there's no justification for joining the bars. Whereas over here, when we have continuous data, because it's not discrete numbers, we usually end up grouping the data and we make a continuous scale down the bottom. So if your height is 180 centimetres, the next division might be 185, but there could be people who are 182 or 183. So you've grouped your data and made one column, and the columns are continuous. And remember, if the columns are joined and it's continuous, we're talking about a histogram. So no gaps between those. We've still got frequency on the vertical scale, but this time we've got a continuous scale on the x-axis. The concept of column width you need to understand, class interval and class centre. So where's the centre of your class? But we'll be doing more work on these shortly. This is just a quick overview. So group data, if it is continuous, or you may have large amounts of discrete data. Not so much as there's large amounts. I'm going to change that. If you've got, say, a large range, so if your numbers are going from really high to really low, that's where you might want to group the data. So let's change that to large range. Doesn't matter if we've got lots of data, but there's only 4 or 5 different numbers, but you don't want a column graph with 20 different columns. That gets a bit unwieldy. Modal class, so if we're talking classes, the modal class is the most common class. And that's obviously coming from the term mode, the most common. So that one you should know. Okay, this next one here we're going to look at in class, so I'll leave that for us to talk further, and we'll also be looking at using your calculators to generate your statistics. So that's what we'll be doing in class. So meanwhile, make sure you know all those terms and look forward to seeing you in class. Thanks for listening. Bye for now.